Okay, 1.3 geometry. Very old term one, but you know we need it for the final. Let's do it. Okay, before starting out, uh, it's all about the circle theorems and the angles. I'm not going to explain all of them at the start. I'll just explain them as we go. Question one, they ask you to find the length of the arc. Remember that the length of the arc, I don't know if this is included, it's definitely not part of 1.3, but I remember they put it in the quiz and none of us knew it, but they still brought it in the exam. Okay, the length of the arc is the angle theta over 360 times 2 pi r. Okay, this is the only heavy formula in this section. We want to take a look. Angle A is 45 degrees. Okay, theta would be the angle for the arc. They give us angle A is 45, okay, and they want us to find the length of arc ACB. ACB, this arc, okay, so we need the angle for this arc. Can we find it? I think we can, right? That the length of the angle for this arc, the measure of this arc ACB would just be 360 minus this blue arc AB, right? So can I find arc AB? Yes, we can. Okay, if this angle here is 45, they told us it's isosceles. Obviously, it's isosceles because O is the center, for this radius is congruent to this radius. If this is 45 and it's isosceles, that means this is also 45. So 45, 45, that means this is 90, right? Because 180 angles in a triangle add up to 180. So 45 plus 45 is 90. 180 minus 90 is 90. So this angle here is 90. So that means this arc over here is 90. So that means the red arc ACB, let me switch to red. The red arc ACB would be equal to 360 minus 90, which is 270 degrees. Okay, so can I solve it now? It will give me 270 over 360 times 2 times pi times r. My radius is 2, right? So it's gonna get 270 over 360 times 4 pi, because 2 times 2. Okay, if you put this on a calculator, you're gonna get 3 pi. Okay, they want you to keep it in terms of pi. Okay, so you're gonna get 3 pi, so k is 3. Okay, question 2. Okay, PQ is a diameter with length 10, okay, and PR is a chord, PR is 6. What is the area of PQR? Okay, before continuing, okay, this angle here will be 90 degrees. Okay, remember that the angle, okay, the inscribed angle of a semicircle will always be 90 because this angle here is inscribing this arc over here. And this arc obviously is 180. Why? Because it's cut by a diameter. You know that the diameter splits the circle into two equal semicircles, and each semicircle has a length of 180 degrees. If this is 180, this over here is 90 degrees. Okay, and we said this is 10. Okay, so that means I have a right triangle, okay, with hypotenuse 10 and with leg 6. They want us to find the area of it. Can I find, okay, you know the area of a triangle is base times height over 2. So first I'm actually going to need the base, right? The base. Can I find the base? Of course I can. Pythagoras theorem. Let's call this base x. It's going to be 6 squared plus x squared equals 10 squared. You're going to get x squared equals 10 squared minus 6 squared, which is 64. Okay, x squared. You're going to get x equals 8. So my base is 8, okay? Now, can I find the area? Of course I can. Okay, my base is 8 times the height, which is 6, not 10, 10 is the hypotenuse. Divided by 2, you're going to get 24. Okay, uh, question 3. Okay, these questions, I'm sure they're going to get one of them. Like question 3, uh, uh, something like question 3, I think question 7. Oh, no, question 7 is easy. Question maybe 5, I think it was. Where's the hard ones? This one, okay. Yeah, something like these. I'm sure they will get in the exam, 100%. Okay, so let's start. Okay, the first thing I want you to pay attention to is read the question. Usually, when they say points K, M, N, Q, and P lie on the circle, they say this on purpose. When they say lie on the circle, you remember when you have any circle and you have a quadrilateral with all four endpoints on the circle, we call this quadrilateral cyclic. Okay, what are the characteristics of a cyclic quadrilateral? Opposite angles are always supplementary, so they add up to 180. Okay, so I'm gonna add this to a new page. Okay, that's always something you want to pay attention to. When they put it in the question, that means they're trying to tell you you're gonna have to use the cyclic quadrilateral, Okay, let's take a look at the angles we have here. They want MKN, okay, MKN. Okay, MKN would be this one over here. Okay, we can see MKN is inscribing this arc over here. Okay, can I find the measure of this arc? I think I can. Always remember, you know, the measure of this arc would be the measure of the central angle, right? The central angle is the measure of this arc. Okay, can I find the measure of the central angle? Let's take a look, okay? I want this angle here. We can see that this angle is part of this triangle over here, okay? Remember they said O is the center. So that means if O is the center, that means this is a radius and this is a radius. So that means this is isosceles. That means if this angle is 36, this as well is 36. And if these two are 36, that means this one will be 108, because you remember that all angles in a triangle will add up to 180. So if this is 108, that means this arc is 108. And we said this angle inscribes it. So it's half of this arc. So half of 108 is going to be 54. So that's why MKN is 54. Okay, so let's erase this. We now know MKN is 54. Okay, what do they want now? MPN. MPN. Let's see MPN. MPN also inscribes this arc MN. MKN inscribes this arc MN. And what did we say about two angles that inscribe the same arc? We said they are congruent. So this is 54. This also would be 54 since they inscribe the same arc MN. Okay, how do you know what arc every angle inscribes? Take a look at the endpoints of the arc, MKN. Obviously, we're not going to look at K. We're going to look at the endpoints, M and N. Connect them, and that would be the arc is inscribed. Because some people still, they find it tough to figure out what arc we're inscribing. So we're done with this one. PMO. Okay, PMO would be this here. Okay, you can see that PMO is part of this big angle, right? Okay. And do we have the angle opposite to it? Yes, we do. And we know that we're working with a cyclic quadrilateral. So the cyclic quadrilateral means that opposite angles are supplementary. So if you add these up, you're going to get 180. Okay? So if I want to write this for you, angle KMN, which is this big red angle over here, plus angle KQN, which is this 94 over here, will be equal to 180 because opposite angles are supplementary. What is angle KMN? It's 28 plus, let's call this X. Okay, let's call this X plus 36. And then KQN would be 94. So can I equals, we know this equals 180. Can I find X? Akid you can. Subtract everything on the other side, you're gonna get 22 degrees. Question 4. Okay, why, you see here we use the cyclic quadrilateral. Okay, again, when they say they all lie on the circle, always anything, think, no, why would they tell me they lie on the circle? Obviously, because they want you to use cyclic quadrilaterals. Okay, they gave us, again, A, B, C, D lie on the circle. Remember, A, B, C, D lie on the circle. Okay, the measure of AOB is 104 degrees. Okay, what do they want? They want the measure of angle ADB. ADB over here. Okay, the measure of angle ADB, how would you use? Okay, the measure of angle ADB would be, you know, before moving to ADB, let's see what's given to us, okay? We have this angle 104, right? This is the central angle, right? Because they said this is the center. So if this is the central angle, that means the arc ADB over here is going to be 104, right? Because it's equal to the measure of the central angle. Okay, and I put the ADB, right? ADB, let's see, let's write it. ADB actually inscribes this arc ACB, right? So ADB, angle ADB over here, starting green actually, angle ADB over here inscribes this blue arc, right? So it would be half of this blue arc. So let's say angle ADB is equal to half of arc ACB. Okay, I mean, I have this red arc and I want the blue arc, which is ACB. Can I find it? Of course I can. I can just do 360 minus 104 and I'm gonna get 256. So now I know that angle ADB will be equal to half of 256, which is 128. That's it. So with geometry, yani, you really have to use your head. No, you can't. Or you know what? Another way you could have done here. Another way you could have done here would be, since this angle here is 104, this arc over here is 104, right? Okay. And remember they said they lie on the circumference of the circle, so they're cyclic. Okay. and we want this angle over here. So since we're working with cyclics, it will always be the angle opposite to it. Okay, so if I add these two, I get 180, right? These two green angles. Okay, because they're opposite angles on a cyclic quadrilateral. Okay, can I find this green angle? Of course I can. Doesn't it inscribe this red arc? So that means it will be 52, right? So if I add this 52 and this angle, I'm gonna get 180. So 52 plus x equals 180. I'm gonna get x equals 128. So this way also works using the cyclic quadrilateral. Whatever you find ideal for you. Okay, at the end geometry you can solve any question with there's more than one solution to almost every question. The points A, B, C, and D lie on the circumference of the circle. Again, pay attention. They're saying they're lying on the circumference of the circle, and for a reason. They're saying AB equals BC. Okay, so this is equal to this. So this is isosceles, obviously. DB equals DC. DB, this one here, equal to DC. So this is also isosceles. Okay, and they're saying angle ACB is 48. They want you to find angle DBC. DBC will be this one over here. So look, another way I solve this, I saw these congruent sides, okay? So if this is 48, the first thing I thought was this over here is going to be 48. Because isosceles triangle, base angles are congruent. Okay, and then, it took me a while to realize this. But after taking a good look, okay, this angle is going to be equal to this angle. Okay, remember always in a circle, when you see the Z shape, okay, these angles will always be congruent. Okay, always whenever you're seeing the Z shape in a circle, or like whenever you have lines intersecting each other, these two angles are going to be congruent. Why? Because they both intercept the same arc. They both inscribe the same arc. You see this one over here, they both intercept the same arc. Like look, this one here intercepts like this. This one here intercepts like this. Okay, so they both intercept the same arc, hence they will both be 48. The next thing you're going to want to look at is this triangle over here. Okay, finding angle B is going to be very easy now. Okay, since this is an isosceles triangle, obviously here base angles will be congruent, right? So if this is x, this will also be x, right? Whenever you have an isosceles triangle, you have the vertex angle, we call this the vertex angle, and you're asked to find the base angles, you always do 180 minus this angle, okay? Gets me 132. So now I know that some of these two angles are 132. And since they're congruent, I just divide by 2 and I get 66. So this each angle here is 66, and this one also here will be 66. So maybe in the exam they ask you to find this small part over here, this small part. If they ask you to find the small part, you just do 66 minus 48, and you would get 58. No, no, show 58. 18. I mean, that's pretty much it for this one. Okay. Might take you, a few seconds to take a look at it and see, but okay. See, this one, I think they're gonna get something like this. Maybe written part, maybe, I don't know. But whoa. For the written part, Akid, the regional said she was gonna bring one of the top questions mentioned in the material at the end. Okay, she said, I think it was from top question 78 to 81 or something like this. She said she will bring one of them in the written. Okay, so please make sure to study them. Okay, here the diagram below shows P, M, K, and N on the circumference of a circle. Again, they're telling you they're on the circumference of the circle. Akid, you're gonna use the cyclic quadrilateral. Okay, especially when they draw it for you like this. Okay, AB is the tangent to the circle at P. Okay, fill in the blanks. P and K. Okay, P and K will be 90 degrees. Okay, it's obviously 90. Okay, why? Because PK is a diameter. Okay, PK is a diameter. How do you answer diameter though? Okay, they should tell you that PK is a diameter, but we know PK is a diameter. O is the center. Okay, it runs through the center. Yeah, since it's a diameter, okay, I told you always the angle inscribed by the diameter is gonna be 90 because it inscribes this semicircle. Okay, but don't have any P and K. Yeah, so it's gonna be 90 degrees. Okay, and obviously if this is 90, P and K is 90, okay, this one will be 90 because opposite angles in a cyclic quadrilateral, this is cyclic because all four endpoints are on the circle. Okay, opposite angles in a cyclic quadrilateral are supplementary. Okay, they add up to 180. So this is 90, okay, this is 90. So 90, 90. Okay, هلا بدهم NPK. NPK. Can we figure it out? How much is this? It's gonna be 47. Why? These two angles add up to 90. Why? Okay? Always remember that the radius is perpendicular to the tangent. Okay? So this is 43, this is going to be 47 because they have to add up to 90 since they're always perpendicular. Radius perpendicular to tangent. Okay? So that means NPK 47. Okay, yani this one here is going to be 47. Okay, okay, if this is 90, this is 47, this is going to be 43 because this is a triangle over here. Okay, and angles in a triangle add up to 180. Okay, so now that I know this is 43, this is 47, if you add these up, that means this big angle is 90, right? And same thing, if this is 47, if this is 47, the small angle here is going to be 43 because same thing, they add up to 180 in a triangle. Okay, so if this is 47, 43, 47, if you add these up, isn't this whole angle just 90? Yes. So now I have four right angles. So what is this quadrilateral? It's obviously a rectangle. It's not a square. Okay. Uh, it's not a square because if it was a square, this would be 45. Okay. Question 7. Uh, the diagram below shows points M, N, K, and P on the circumference of a circle. Okay, M, N, P, and K, circumference of a circle. M, N, P, K on the circumference of a circle. Okay, with center O, segment MP is the diameter. I told you MP is the diameter. MN equals KN. MN equals KN. Okay, and angle OMN is 58. Okay, let me make this a bit bigger. Okay, and I want to see what they're asking. I go down. Okay, they want the measure of MPK. So they want the measure of MPK. So this one over here. Okay. Over here, you're gonna have to use congruent triangles. Okay. Uh, the first thing you're gonna take a look at, if this angle is 58, this angle will also be 58. Okay, since these two radii are congruent. Okay, we're gonna write it like this. These two radii are congruent. Base angles will be congruent. If this is 58, 58, this will be 64 because all angles add up to 180. Okay, take a look here. These that's also another radius, right? So these two triangles are congruent because this side is congruent to this side. This side is congruent to itself, so that's side, and then this side is congruent to this. So using SSS, these two triangles are congruent, okay? So that means this angle, if this angle is 64, this angle will also be 64, okay? So if this angle is 64, this angle is 64, how much will this one be? This will be 58. No, 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 52. 52 because all angles add up to 180 because it's a straight line. They said it's a diameter, right? Where MP is a diameter. So, you know, on a straight line, if you have this is 30, مثلا, this will be 150 because they add up to 180. Okay? So that's how I get this angle up here is 52. Okay, now let's erase a bit. Okay, what do we want? We want angle P. Okay, this is 52. We want this one over here. Okay, isn't this also an isosceles triangle? Yes, because these radii are congruent. So this is 52. This will be x. This will be x. Can I find x? Of course I can. So 2x plus 52 equals 180. Because all angles add up to 180 in a triangle, صح? So 2x equals 180 minus 52, which is 128. You're going to get x equals 64. Okay. Question 8. Uh, okay. Can go up. Okay, like this. You have the shape here. A, B, C, and D are points on the circumference of the circle. AC is a straight line, and the measure of angle BDA is 56. They want BAC. They want this one over here. Okay. Okay. If this same shape comes in the exam in the multiple, just do 90 minus 56. Okay, 90 minus whatever angle they give you. Okay. Because usually with these circles they give you the same types of questions. But look, this is why. This angle over here is obviously 90 because it intersects the diameter, right? The diameter, the angle formed by two segments in the diameter is 90 because it intercepts this 180, whatever. Okay, 90. This angle over here will also be 56. Okay, why? Because this intercepts this arc, right? What also intercepts this arc? This angle 56 intercepts this arc because look here. This angle 56 is like this. Intercepts this arc. So this one also intercepts this arc. I just want to show you how. Since they both intercept this arc, that means they're both equal. So this is 56, this is 56. Okay, so now I have this triangle. This angle is 90. This angle is 56. Can I find this one? Just do 180 minus 90 minus 56, you get 34. That's it. Okay. Always remember, like I told you, whenever you see this crossing shape inside the circle, that means you're gonna have two congruent inscribed angles because they inscribe the same arc. Okay. Question 9. Okay. Oh, this one I don't like it. Again, these long questions, I think they could bring one of them in the written. Fa, like you see these, if qx equals 12 centimeters, and how much is qu? So yeah, just in case, you never know. Let's see. The measure of angle WUV. Okay, they gave us. Wait, let me see the question one more time. Yeah, okay. They're both tangent. Okay, WOU. They gave us WOU is 80. So this one here is 80. Okay, they want you to find WUV. 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 Okay, whenever you see an angle like this, okay, intercepted by a tangent, it's always half of the arc it intercepts. Okay, how do you know what arc does it intercept? You look at the two segments that form. Okay, you look at the two segments that form this angle. Okay, it will be this segment here and this segment here. And what arc does it intercept? It intercepts this red arc over here. Okay, this is how I solve it, but the book I think solves it a different way. But this way is always correct. Okay, so I want to find half of this red arc. Do I know how much red arc is? It's 80. How do we know? Because the central angle is 80, and the central angle always corresponds to the arc. Okay, so now I know this one here is 80. So this, our blue angle WUV is half of this arc, so it's going to be 40. Okay, let's see now. YWX. YWX. This one over here. Isn't this just the same thing? Okay, if this is 80, obviously this is also 80 because vertical angles, right? They're equal to each other. Okay, and this one here intercepts this green arc, right? Same ideology. If this is 80, this is going to be 80. And this is half of 80, so it's going to be 40. Okay, now UYX. UYX. Where's UYX? UYX is going to be this one here. UYX. Over here. Okay, obviously this is an inscribed angle, and it inscribes this blue arc over here. This blue arc here is going to be 100. Why? This is 80. We said this is 80. Okay, and this is a straight line, obviously, right? Okay, so how much is this going to be? It's going to be 100, right? And the measure of the arc corresponds to the central angle, so this is 100. So this is going to be, the red arc inscribes it, so it's going to be half of it, so it's going to be 50. Okay, so 50. Okay, now YXW, okay, it's going to be the same thing, right? Should be. I can kind of see the pattern they're using here. YXW, okay, yeah, same exact thing. This inscribed angle inscribes this arc, and this, since this was 80, this was 100. Okay, this is 100, half of 100, 50. Okay, if QX equals 12 centimeters, they said this is 12, how much is QU? Okay, it's 12. It's a theorem. Okay, tangent points, two tangent segments coming from the same external point are congruent. Okay, these two are tangents, and they're coming from the same point, Q, hence they are congruent. Okay, question 10. This quiz is very long, 28 questions. I don't like it. Okay, this one, I think, if I'm not wrong, came in one of our periodics. I remember it came. If not this, I think one that looks like it. Let's see. So they want, okay, let's see what we have. We have all of these angles here. They want angle Z. Okay. Okay, angle Z is obviously 90 because angle Z inscribes this KL, right? It inscribes it. Okay. And what else inscribes KL? This one over here. So since it's two inscribed angles inscribing the same arc, they will both be congruent. So this is 19. This will also be 19. Okay. X. Okay. X will be, what's X gonna be? X is gonna be 80. Ah, this is 80. Okay. They said GM is the diameter, right? This one here is the diameter. Okay. So that means this this angle here will be 90. Why? Because it's a diameter. Angles formed by diameter are always 90 degrees, right angles, because it intercepts this 180. Okay. And they have this angle 72. Can I find the third angle in this triangle over here? Yes, I can, right? Just do 180 minus 72 minus 90. I'm going to get 18. There you go. Now, we know this is 19. We know this is 18. Okay. Can I find angle W? Okay. Angle W inscribes this over here, right? What else inscribes this angle X? and we found x is 18. So see these two angles which inscribe the same arc, so they are congruent. So if this is 18, W will also be 18. There you go. Okay, so now we have, this is over here 18, this is 19, this is 18. They want angle Y. Okay, Y inscribes this. Oh, okay, well, how am I gonna find Y? Wait, let me see. Okay, so after looking in the question, uh, I see GK is parallel to NM. I didn't really realize that at the start. So this over here is parallel to this one over here. Okay, what do we know about two parallel lines? Okay, we know that the transversal cuts them. Okay, this is the transversal. So I'll use red because red stands out a bit more. Okay, so these two are cut by this transversal over here. Okay, what do we know about alternate interior angles? What do we know about them? We know they are congruent, right? So y in this case will be equal to 19 plus x. And do we know what x is? X is 18. So y is 19 plus 18, which is 37. Okay, that's why y is 37. Question 11. Okay, I think this is the one we got in our periodic. I remember seeing this shape before. So all of them could come. Please make sure you know them. No, they're not that hard. Wallah. The measure of angle RST over here, okay, is gonna be 67. Why is it 67? Okay, for this took me a bit too long, way longer than needed. Do I have a calculator over here? Yes, I do. Okay. Can I make this big? Okay. Look here. They want angle RST. Okay, RST. They want this whole thing. And it took me a while to realize. Yeah. This is one full triangle over here. Okay. Like this. So I thought if I can find this maybe, okay, I can just do 180 minus 29 minus this angle and I can get this. So I started thinking, what is this angle? I started looking at the shapes, and this angle is actually opposite to this angle over here. Okay, and this is a cyclic quadrilateral. If you take a look, P R S T, it's a cyclic quadrilateral. I'm pretty sure there's a different way to do this because I think my way is a bit far-fetched. Okay, so it took me a few steps to realize this. المهم, so this angle is supplementary to this angle over here. Okay, and Anna, I realized this angle over here is equal to 67 plus 29 because it's an exterior angle, and exterior angles of a triangle are equal to the sum of the remote interiors. 29 plus 67, let's do 29. Wait, hold up. 29, 29, plus, no, 29 plus 67. 96. Okay, so that means this one here is 96. Okay, so this angle over here will be supplementary to this 96, so it will be 180. 180. Wait, 180 minus. Oh my god, minus 96. 84. Okay, so this angle here is 84. So I started thinking, okay, 180 minus 29 minus 84 to get this angle here, because it's a full triangle. 180 minus 29 minus 84, and you're gonna get this angle here is 67. Okay. Okay, and then after taking another look, okay, I said, okay, I have another triangle over here. I draw it in yellow. Okay, this yellow triangle over here. Okay, and I said, wait, I think I can find this angle because I have this angle over here, and I have this angle. So can I find this third angle? Yes, I can. 180 minus 96 minus 44, I get 40. So this is actually what they're asking for in part C. P, oh no, they're not asking for this one. They're asking for PRT, which is also 40. I'll explain why in a second. Okay, after I figure out this is 40, okay, I took a look. They want RSP, so they want this one here. Okay, I know the full angle is 67, and this one here is 40. So this angle would just be 67 minus 40, which is going to be 27. Okay, so this is going to be 27, and this is 67. Okay, then they want the measure of angle PRT. Okay, I'm gonna erase this a bit, okay, so it's a bit clear. 67 is the full thing. We got this is 40, and this is 27. Okay, PRT would be this one over here, okay? And this one would be inscribing this red arc over here. There you go. And this yellow angle down, the 40, actually also inscribes that same arc. If you take a look, there you go. See, they both inscribe this. So since they both inscribe the same angle, this one will also be 40 degrees. Okay, it's a bit of a tough one, I understand, but I hope someone has a different way to solve, because my way is a bit confusing. Uh, if you have a different way to solve, please write in the comments. Question 12. Uh, in the figure below, S is tangent to the circle. Okay, look من الآخر. Whenever you see a shape like this, just do 180 minus 50 divided by 2. Okay, you're gonna get 65. Okay, this angle here, it's a theorem. This angle here is always equal to this angle here. Whenever you have a triangle and you have the angle formed by the tangent, it's equal to the angle down here. And I know the question comes copy paste in the AMS, so and periodic. Okay, question 13. Okay, whenever it's in the exterior, you subtract. Okay, whenever you have an angle in the exterior and you have it intercepting two arcs, you always do arc 1, let's call it A1 minus A2 divided by 2. If it was in the interior like this, you do A1 plus A2, but we're not working with interior, we're working with exterior. So we're going to do 100 minus 48 divided by 2, and you get 26. Yeah. Question 14. Okay, now it's in the interior. Okay, so arc 1 plus arc 2 equals interior angle. So arc 1 plus arc 2 divided by 2 equals interior angle. Okay, now we're adding and divided by 2. When it was outside, yeah, when it was outside, okay, then we would have subtracted, but here it's in the interior. So you add. Okay, arc 1 would be x, arc 2 would be 50 divided by 2 equals interior angle 70. Okay, to get rid of this 2, we can multiply by 2 on both sides. Okay, and you're gonna get x plus 50 equals 40. Okay, and you're gonna get 140. Sorry, you're gonna get x equals 90 degrees. Okay, so 90. Question 15. These ones are a bit easier. Okay, again, same thing. Okay, this arc, whenever you have a triangle and an arc, they're always equal to each other. Okay, and I know it comes the exact same in the AMS. Okay, so this arc is equal to this arc. Okay, because they both, sorry, this angle is equal to this angle because they both intercept the same arc. They both intercept this over here. Okay, you see, if you can see, this intercepts. Look at the endpoint and connect it to here. It intercepts. By then, these two endpoints, connect them. You get that arc. Question 16. Okay, what is the value of x? Okay, obviously this is cyclic. Okay, so that means if you add them up, they're supplementary. So y plus 70 equals 180. You're gonna get y is 110. Okay, then x plus y plus 62 equals 180. X plus y plus 62 equals 180. So x plus 110 plus 62 equals 180. You're gonna get x equals you're gonna get 8, obviously. Question 17. See, these ones are a bit easier, so it's easy. Okay, they want the value of y. Okay, y would be okay, you could do this. X would be half of 114, so it would be 67. No, not 67, 57. 57. It would be 57. So this angle here would be 180 minus 57 minus 64. 180 minus 57 minus 64, which is 59. Okay, so this one here would be 59. So this one here would be double, right? Remember the inscribed is always half, so this one would be double of 59, which is 180. Another way you could solve is multiply everything by 2. Okay, you could do, some people memorize, because some people memorize ways to solve. Okay, some people do 360 minus 114 minus, since this is double, 2 times 64, and you get 118. Okay, because this arc will be 128. Okay, 360 minus 124, sorry, 360 minus 114 minus 128 gets you this y. So whatever you want, it's fine. Okay, again, it's in the exterior, so arc 1 minus arc 2 divided by 2 equals my exterior angle. So 220 minus 140 over 2 equals x. 220 minus 140 is 80 over 2 equals x. You're going to get x equals 40. Question 19. Again, same thing. Exterior, so you do arc 1 minus arc 2. 178 minus 96 divided by 2 equals y. 178 minus 96, I think it's, what is it actually? 82. 1, 2, 98. Once, no. Yeah, 170. Yeah, 82. So you're going to get 82 over 2 equals y. You're going to get y equals 41. Okay. Question 20. Okay, inshallah they're all easy. Okay, what is the value? Okay, look. Whenever you have, again, tangent, it's always half, the angle is half of the arc it intercepts. Okay, what does it intercept? Take a look at the endpoints. These are the endpoints of the angle. Connect them, you get this arc. So it's going to be half of this arc 130, so it's going to be 65. Question 21. Okay, what is the value of y? So they want this top angle here. Always remember that this angle here is equal to this angle here, right? So this is 68. So this is 68 as well. Okay, so how much would this top angle be? 120, 136. It would be 44. 44, yeah. So this angle will be 44. And the arc is always double the angle, right? So it's going to be 88. Question 22. I'm going a bit fast because these questions are easy, you know. Okay, again, they want x. Always remember this angle is equal to this angle. So how do you find this angle? 180 minus 48 divided by 2, because these are equal to each other. Okay, you're going to get 132 divided by 2, which is 66. Yeah, I think this is a repeated question. Question 23. Okay, what is the value of x? Always remember these two are equal to each other because they intercept the same arc. Question 24. This came. I remember this coming. Okay, what is the value of x? Okay, some people just add these up and you get 130. Okay, why can you add it up? I'll tell you why. Okay, this here, this x, you have to connect the endpoints of the angle. These are the endpoints. Connect them, you're gonna get this massive arc over here. Okay, so if you can split it up into two pieces, I can get this piece here, which would be 150, this red piece. Okay, why is it 150? Because it's double of 75. So, and then I'd have this piece, this blue piece over here. Okay, which would be 110. Okay, so this yellow arc would be 150 plus 110, which would be 260. The full thing would be 260. And you know, this is inscribing, so it will be half, right? It will be half. So it will be 130. Is that actually the way to do it? Yeah, it would be 130. Question 25. Okay. Uh, okay. This is different than the ones we had before. Okay. Some people will put 130 directly. Okay, if I were to show you the difference between this, see how this is a line connected to the triangle, and this one over here. Let me show you. And this one over here, this is a tangent. It's not connected to the triangle, it's coming from under, it's a tangent. As well as here, it's a tangent coming from outside the triangle. But here, it's directly from, where is it? Question 25. It's directly from inside the triangle. So what you do here, look at what you have given here. If this is 140, this here would be 70. Okay? And remember that this is an exterior angle to the triangle. It's not formed by a tangent, it's part of the triangle. Okay? So it's going to be equal to these two plus each other. Always remember when you have a triangle, okay, and a side of the triangle continues outward, this angle, we took it in grade 8, is equal to the sum of the remote interiors. So this angle x would be equal to y plus z. Okay, always remember that. So see here, this angle, it's part of the triangle, but it's on the outside. The exterior angle is always equal to the sum of the remote interiors. For 70 plus x equals 130, you're gonna get x equals 60. Okay, please pay attention, don't make the mistake and put 130. Well, it's obvious, it's an acute angle, it's obvious it's not 130. Okay, what is the value of x? Okay, you do arc 1 minus arc 2, since it's an exterior. Arc 1 minus arc 2 equals 45. So 105 minus x over 2 equals 45. Arc 1 minus arc 2 over 2 equals the arc out equals the angle outside. Multiply by 2, you're gonna get 105 minus x equals 90. Okay, you're gonna get x equals 15. Okay, 105 minus 90. Question 27. درش يخلص الquiz. Okay, pay attention here. It's in the interior, so we do arc 1 plus arc 2. So x plus 130 divided by 2 equals. If you put 70, you're gonna get it wrong. Okay, 70 is for these two. We don't want these two. We want the other two. Okay, pay attention. We want this angle here. This angle is going to be 110 because it's a straight line, and obviously straight line يعني they're supplementary linear pair. Okay, so this is 110, so they're going to equal 110. Multiply by 2, you're going to get 220 equals x plus 30. You're going to x plus 130. You're going to get x equals 90 if you subtract. Finally, the last question of this. How long is it? 40 minutes. Okay, the measure of arc xw. Okay, xw. Okay, take a look here. They said VW is the diameter. يعني أكيد this angle here will be 90 because it intercepts a semicircle, right? So it's gonna be 90. Okay, if this is 90, how much is this? It's obviously gonna be 40, right? Because 180 minus 90 minus 50 gets me 40. So how much will x be? It's gonna be double of the angle, right? This is half, so it's gonna be 80. Okay, how about part B? In the diagram below, they give us 44 here, and they want x. Okay, they're gonna be equal. Why? What did I tell you? When it's a tangent, then they're equal. Okay, this is a tangent here. It's not connected to the triangle. It's coming from outside of the circle. To prove it, because this x inscribes, look at the endpoints of it, inscribes this arc. How about the angle outside? It also inscribes that arc. Take a look at the endpoints of it here and this segment here, 44, right? So they're equal. That's it for 1.3. Very long recording, but thank you so much for watching.